Most ionic compounds form ionic solids or crystals. And so the crystal lattice is made up of repeating units called formula units. And so I'm going to call these formula units, but no, we could also call these repeating units because that's essentially what's happening there. They're repeating. Now, take for example table salt. The ionic bonds of attraction between the chloride ion and the sodium ions around it hold the crystal together. So I'm going to put here ionic bonds of attraction. That's what's holding everything together. Now, the crystal of sodium chloride is cubic. So I'm going to put that over here. The crystal is cubic. So for every sodium ion, you have 6 chloride ions surrounding it. And around each chloride ion, you have 6 sodium ions surrounding it. So if you think about this right here, that has to go right there. There has to be sodium ions all around this, but then there also has to be chloride ions around every sodium ion. And so it's very symmetrical, 6 chloride ions around every sodium ion and 6 sodium ions around every chloride ion. Now, generally, ionic compounds stay bound in crystals unless dissolved in water. So I'm going to write here, they stay bound unless dissolved in water. And then at that point, you all know if you put salt in water, the salt's going to dissolve and you're not going to see the salt in there anymore. And so once dissolved, the ions are going to float freely in the solution surrounded by water molecules. Now, ionic crystals come in many shapes and colors. Think about any type of gem that's very colorful. That is going to be probably an ionic crystal. So hopefully through this you have a better idea of the state of most ionic compounds. And it's important to remember that most ionic compounds form ionic solids or crystals.